Hello everyone, welcome back to Smart Contract Labs. So in today's lecture, we are going to work on payment splitting system using fallback function. So let's understand what is payment splitting system and how we are going to implement it using fallback function. So uh, here is a description of this smart contract. So in this smart contract, what we are going to do, we divide the payment among the multiple beneficiaries and by with the help of a fallback functions. So we will understand first what is fallback function, and later on we will do the coding part. So let's understand it's basically a special function available to a contract. So whenever you are calling a function that is non-existent function, that means that is not available, you are calling you are calling some other function which is not available in your contract, then it automatically call which function? The fallback function. And you have to mark this fallback function as external, and it has no name, no arguments, and it cannot return anything, and it can be defined one per contract, and it is not, if not marked payable, it will throw exception if contract receive plain ether without data. So fallback function is specifically designed when you want to receive ether in your contract by using we can have the fallback simple fallback function without any name, or the receive function whenever you are transferring some you want to receive ether in your contract, and it also called or automatically when there is no when you are calling the function which is non-existent in your contract. And there are certain requirement whenever you declare this fallback function, there should not be any arguments, it should not return anything, and it should be marked as external, and we can only define it one per contract. So let's understand. So this is what the fallback function, and while we do it we do the coding part, you will learn more about it. So here what we are going to do first, we have a owner. We set the owner in the constructor, and this owner is allowed to update the list of beneficiary as well, who are beneficiaries. So among the beneficiary, we are going to split the amount, right? And and so we will create one only owner modifier that restrict the function to be called only by the owner. And here we are going to design a fallback function as a receive function, which is same as the fallback function, and is triggered. It triggered automatically. There is no need to call it when the ether is sent to the contract without calling any specific function, because whenever you are calling any specific not calling any specific function, but still you're calling the non-existing function, so it automatically executes the fallback function on place of it. So and it so in this function, what we are going to do, we are even to divide the ether among the predefined beneficiaries. And the beneficiary, we will create one beneficiaries array that hold the addresses that will receive the splitted amount, right? So let's do the coding, so that then it will be more clear to you to understand what is the fallback function and how we are going to split the amount. So here I have already opened the Remix ID. Let's go to the Smart Contract Lab folder and create a new file. And here I just write the name of this file as payment splitting contract. And what I do, I just copy the two basic information from the other file to payment splitting file here. And let me zoom it first. So what we are doing, so first line specify your license identifier, and second line specifies the compiler version, and we are working on the latest version, that is 0.8.24. And let's create a contract first. So first I'm creating a contract and name it as payment splitter payment splitting contract. And so first, what we do, what we create a owner, because there are certain things that should be, there are certain function that should be executed by the owner. So first create the owner address, and then create the address of the beneficiary among which we will divide the payment. And here I'm creating the array of addresses so that we can have the multiple beneficiaries. Done. And next, we will declare one public variable that is of integer type and name it as amount per beneficiary, in which we will store a splitted amount, right? Then, so these are the following variables we need for this contract. First one is your owner. Second one is your beneficiaries. So the amount we are going to divide among these beneficiaries, and this is hold the amount value that we have divided among them. Now next, just work on the modifier. So here I'm creating one modifier called as onlyOwner. So that we can allow this constraint that only owner can execute this function. So here I'm using a required statement, and in this required statement, I'm going to write only message.sender, that is your global variable, it's equal to the owner address. If it is equal, then it's fine. Otherwise, you have to display error message as only the owner can call this function. And you just close this modifier uh, with this underscore sign, right? Because this is the modifier always impose the condition on the functions. So this will replace the rest of the statements of the function. So let me check what is okay. Expected this, or it should be modified. That's right. Okay, it should be owner, OWNER. Now it's fine. Now next, we will create a constructor to initialize the beneficiaries addresses. So constructor. So I'm creating here the parameterized constructor, and I'm taking the array of addresses as a parameter so that I can initialize all the beneficiaries. Done. So first you have to initialize the owner with the global variable, that is your message.sender, and then initialize your beneficiaries as equal to underscore beneficiaries, like this, and that's all. So, and this variable we are going to create under the fallback function. Now next, work on the function. So first function is that update the beneficiary. If you want, you can update the beneficiary addresses as well later on, and this should be done by the owner. So I'm gonna use this only owner modifier with this function, beneficiaries. And here I'm going to pass the parameter, that is array of address, and for new beneficiary, to store the value of new beneficiary. And here new beneficiaries, right? I just make this function as public, and it should be only executed by owner. And just update the variable beneficiaries should be equal to the new beneficiaries. So this is how we can update the beneficiaries addresses with the new one. Now next we have to create fallback functions. Like I told you, in this we are going to create a fallback as a receive function that is triggered automatically when the ether is sent to the contract without calling any specific function. And what it's going to do, it just split the incoming ether among the predefined beneficiaries. So whenever so here we can divide this is how we can it should be receive IV, yes. So now it's fine. So it's a receive function, and it should be external and payable. Whenever we declare the fallback function, it should be external and payable, because it's include the transfer of ether or the so that's why the payment is involved. So it should be And we are using these amounts per beneficiary for dividing the amount. And this is the global variable in which we are going to store the amount that we are going to that we want to divide among different beneficiaries, and it should be divided among the beneficiaries by using this length. It's done. So amount is divided. Now we want to transfer. Now we have to transfer this amount to the different beneficiaries address. And for that we have a transfer function. So instead of a transfer, so we need to use a for loop, because you don't know how many beneficiaries you have currently. So that's why you have to use a for function, for loop for transferring the amount, the divided amount. So I should be less than the beneficiaries dot length, because this is the name of the array in which we are storing your beneficiary details, and just plus it. And here we are so it should be payable first, and then under this we are using this beneficiaries array, and here I'm passing a. And for transferring the function, we have a transfer. So this should be payable, and then transfer here. Transfer the amounts per beneficiaries that we have calculated here, and a semicolon. So by using the for loop, because we have multiple beneficiaries, so that's why I'm by using this for loop, we are just accessing the beneficiary address one by one. For example, for beneficiary 0, we are going to transfer the amounts per beneficiary that we have calculated here. So this is how we are splitting the payment among them. And then that's all about this function. It's done. Right, so this is your fallback function. This should be external and payable, because it involves the so you want to receive the ether, right? So here we are using the message dot value for specifying the ether value, and we are dividing it into the multiple parties, among the multiple parties, and we are just transferring them their amount. So that's all about this code. I hope you understood it, and we have done all the parts here. Now just compile it first. So it is compiled, and just deploy it. So I'm going to deploy it. So whenever you are deploying it, you are calling the constructor. So here in constructor, I have passed the address, array of address. So here I need to specify the beneficiary's address here at the time of deployment. So whenever there is an array in the arguments, you have to specify the value by using this square bracket, and all values should be separated by comma and enclosed under the double quotes like this. I hope it is visible to all. Now I'm going to use two beneficiaries here. So this is your first beneficiary. I'm just copy this address here, and I paste under this first double quotes value here, right? And then I will take the second account and copy it, and paste it in the second double quotes like this. And just use the first address as your owner address and deploy it. So it is done. It's successful. And then it is deployed here. Just click on it and check what are the different functions you have. So amount per beneficiary is 0 now, and you can check the beneficiary's address by using this array. For 0 index, we have this. For 1 index, and so on. Who is the owner? You can check the owner here. Now you can, if you want, you can update the beneficiaries, but and you can see there is no receive function here, because this is a fallback function. It's an external one, so that's why it is not visible here. So it calls automatically whenever you are calling the non-existing function. So how you are going to do that thing in Remix? So Remix is providing the low level interaction through which you can test your fallback functions. So here I'm just using this transact. I'm not here. There is no need to specify and call data, and the value I'm going to specify here, for example, 10. and I'm just transact here. So it is successful and it will execute which function? The receive function. So it automatically call the receive function whenever you are calling the non-existing function, and you're calling the data, you are calling it without any data, right? So now you can check the amount per beneficiary is 5 because they are total 2 beneficiaries. The amount I have specified here is 10. So this is how we can use the fallback function for receiving the ether in your contract. And there are certain conditions with the fallback functions you have to consider while you are defining it, right? So that's all from my side. And the advantage, because of fallback functions, so you can use it for in case of displaying the error in which if so that you can understood that you have executed the non-existent functions and like this. So there are different utilities. Thank you so much for your time. Have a nice day.